Okay guys, so Princeton review, just thought maybe I'll start going over the problems in videos for you. Once again, the videos are really just going to be to help you guys whenever you get stuck on one. But it's also important that you guys do take the time to figure these things out on your own. Now, some problems I'll just do straight up. Some problems I might just give you a suggestion. But let's go ahead and get started here. So for page 264. I assigned numbers 1 and 2. Now these ones I feel are fairly basic and straightforward enough. These are types of problems that we've already done this year. So I'll at least do the first step for you to get you started. And then I'm going to let you do the rest of it, okay? Now as for this one here, we have a square root, which means that we have a fraction power, right? But still, we don't like them on the bottom either, so I'm just going to move that fraction on up to the top and make it negative. From there, I'm going to let you guys handle that. So that's for the first two there on page 264. I'm going to let you guys handle most of them because those ones were pretty easy. But let's go ahead and check out number 270. So our next page is 270. All right. On page 270, I also assigned numbers 1 and 2. All right. Now, for this particular problem, what you're going to do is, for number 1 anyway, you're going to let u equal cosine of 2x, just like that. All right. The next thing you're going to do is you're going to take the derivative. Now the derivative of cosine is negative sine. But this is a chain rule, so we also need to multiply this by the derivative of the inside, which is 2. So I'm just going to put a 2 in the front here and the negative there as well. So there's our, and then we're going to go ahead and get the dx by itself. And then we're going to do our u substitution. Now this whole thing right here is going to be my u. All right. From there, those cancel out, and then I'm going to let you take it from there. Okay? The rest of it's pretty common. I think what makes number 1 hard is that the u is very unobvious. Usually the u is in parentheses or something, but in this case it was just kind of tricky to identify what the u is. All right. Let's go ahead and take a look at number 2. Now in number 2, this is a pretty classic problem. These are the kinds that we did in class. So in this case, notice that the power on the bottom is 1 less than the power on the top, and when that happens, we just let the u equal to that piece that's on the bottom. Okay? But from there, I'm going to let you guys handle the rest. Okay? Let's go ahead and move on to yet another problem. All right, so for number 5 on page 290, I think what's weird about this one is just the way that they're presenting the question. They're asking us to find the area under the curve, and here's my function, from x equals 1 to 2. And so basically, they want us to do an integral, a definite integral, from 1 to 2. And that's it. Because definite integrals are that which tell you the area under a curve. So I'll let you guys take it from there, because the rest is pretty straightforward. All right? Number 6. There's probably not much for me to share with you there either. It's pretty straightforward, just a standard definite integral. Okay? You guys are welcome to ask me for help if you need to, but I'm assuming for 5 and 6 that we've gone over enough content to where those should be fairly straightforward. Let's go ahead and take a look at our next set. All right. So this is on page 310. And I'll start us off with number 1 here. Now for this particular problem, I'm going to go ahead and just work it out for you guys from beginning to end, okay? So we want to take the derivative of this. Now first thing to notice is that we have a chain rule, okay? We have an outside function. And then we have our inside function. So it's going to be a chain rule. So let's go ahead and begin here. The first thing we're going to do is the derivative of the outside. Now when you have a constant multiplier in the front like that and you take the derivative, it just stays the same. Okay? And then when you're trying to find the derivative of tangent, arctangent I should say, the result will be 1 over whatever's inside these parentheses here squared plus 1. Okay? So that's the formula for the derivative of arctangent. Now you might have to go back and look up those formulas, or maybe you've got them committed to memory, but that would be the result there. All right? Then we also need to multiply this by the derivative of the inside. So what's the derivative of that? Well, it might be helpful if you guys know that x over 4 can be rewritten as 1/4 times x. So when you take the derivative of this, it's just going to be 1/4. All right? Now let's go ahead and do a little bit of simplification. So first of all, the 1/4 and the 1/4 come together to make 1/16. Also, this can be squared. It's hard to say just how far they want this thing to be simplified. Then we can go ahead and multiply, so 1 times 1, then we can multiply the 16 all the way through. So if you multiply 16 times x squared over 16, the 16's cancel and you're just left with x squared. And then 16 times 1 is 16. And so there would be our final answer. That would be the derivative of arctangent times 1/4 of x over 4. All right? Now, for number 2, you're going to handle it in a very similar way, but you're just going to have to remember that arc sine is got a slightly different formula. Also, 1 over x, we're going to want to rewrite that as x to the negative 1. Okay? So let's go ahead and find the derivative of this thing. All right. So first of all, once again, we have another chain rule on our hands. We have arc sine as the outward function, and we have x to the negative 1 as the inside function. So the derivative of arc sine is 1 over whatever's on the or square root of 1 minus whatever's on the inside squared. In this case, it's x to the negative 1. Okay? Then we're going to multiply that by the derivative of the inside. The derivative of the inside is going to be negative 1 x to the negative 2. All right? And of course, once again, we're going to have to simplify this stuff a little bit. So let's see. We have 1 minus 1 over x squared, because that's what x to the negative 1 is, times negative 1 over x squared. Okay. Not too bad. Let's keep going here a little bit. We have 1 over the square root of 1 minus 1 over x squared times negative 1 over x squared. And now, for the rest of the problem here, we're going to simplify it so that we can get to the answer that they have in the back of the book. But just so you guys know, from here on out, could they put a question like this on the AP exam? Maybe. But really, in the long run, it's just going to be a good exposure to practice and some neat algebra tricks just to keep you guys sharp. But it's not a huge deal at this point. Just want to make sure you guys know how to do the basic derivative, which we've done. But I am going to go ahead and simplify this. So first of all, let's go ahead and we're going to simplify this piece here. Okay? So let me show you how I'm going to go about doing that. Well, the first thing I'm going to do is I'm going to get a common denominator. So instead of having 1 minus 1 over x squared. What I'm going to do is I'm going to think of this as a fraction of 1 over 1. And then I'm going to multiply the top and the bottom by x squared. That way those two fractions have the same denominator. So by simplifying that, let me put the rest of it there before I go any further. By simplifying that, then I'm going to end up with the square root of x squared minus 1 over x squared. Okay? Now, put the rest of it here still. When you take the square root of a fraction, you guys, that means you can just take the square root of the top and a square root of the bottom separately. Alright. Now, we're going to go ahead and we're going to take the square root of the bottom here, the square root of x squared. Alright? And the square root of x squared is just x. Oh, it's not plus 1, it's minus 1, sorry. Just a second. Now that I've gotten that bottom there simplified as much as I can, I'm going to get that fraction simplified. So I'm going to multiply the top and the bottom here by x. That way this x cancels this x. So let's make some space over here for myself. Okay, so now we have the following. We have x over the square root of x squared minus 1 times negative 1 over x squared. So multiplying a negative times a positive, we end up with negative, right? And then x. 1 times x is just going to be x on the top. And then on the bottom we have x squared, square root of x squared minus 1. And then, of course, this x and this x squared can reduce, so we end up with 1 over x times the square root of x squared minus 1. Now, I know in the back of the book that they have some absolute value bars here. Okay, now, I'm going to explain why those are there. I'm not too sure how in the process of the algebra you would know that that's what you need to have. But what I can say is that when it comes to arc sine here, and you know, I'm just going to have to say, guys, I honestly don't know why those absolute value bars are there. I do know it's right. And the reason I know that is because I graphed this function and I looked at it and I saw that no matter what, the slope's always going to come out negative. And so if you didn't have those absolute value bars there, it's going to be negative. I think maybe the reason, if I could hypothesize, would be because of this piece right here. When you take the square root of x squared, well, true, you get x, but it has to be a positive x. And so even whenever you reduce it, you have to have a positive down there, because when you take the square root of a square, you have to get a positive answer there. So that would be my guess, is it probably has something to do with that. But in all honesty, I'm not going to test you on something that hard. And if you can at least get to this point, you know, without the absolute value bars being on there, chances are you're going to find the right answer on the test anyway. So it's not a big deal, but I think the level of detail they go into there is a little bit beyond the scope of what we need to concern ourselves with. But hey, we got to practice and see some interesting algebra. Let's go ahead and take a look at number 4. All right. So for number 4, we want to evaluate this. Now we're doing the opposite. We're integrating instead of finding derivatives. So first of all, I don't like my dx's up there. I've told you guys that before. I like it here. And this setup here resembles an arc-secant pattern. Okay? And so it's going to be arc-secant of whatever's being squared, absolute value of that, of course, over the square root of this number. Now that's really weird, but we're just going to put pi. Okay? Now, usually we have a nice number there, like a 9, and you guys know when you square root that, you just get 3. But in this case, they've given us a weird number, so we'll just put square root of pi there. And then, of course, we put the same thing in the front here. Now, do they want us to go further than that? And the reason I ask is because technically you're not supposed to have square roots in the bottom, but I looked it up in the back of the book. They're happy with this. Oh, I forgot my plus C. They're happy with this, so when it comes to a multiple choice test, you just kind of got to go as far as you think is easy. Look at your choices. If it looks like you got to go a little further, keep simplifying. In this case, we're good to go. All right, let's go ahead and take a look at number 5. Now, number 5 is pretty similar to number 4. This time, the only difference is that it's fitting an arc-tangent pattern. And so we have arc-tangent. The number here is what goes on top. The square root of this number goes on the bottom. And then we have the same thing out here. And that's it. All right. So that takes care of your Princeton review for the week. Hope it was helpful. And we'll see you guys